get on to the last iOS lecture. So the UK has decided to make its contract chasing app. There is a popular belief now that you can make some kind of a phone app that will perform some kind of automated contact tracing. Now, increasingly, this seems to be pretty much a bad idea. But anyway, there are two ways to do it. One is decentralized, which is what Apple and Google want, where your phone sends a message to phones you get near, and then if somebody tests positive for coronavirus, it tells you, but no central server has all the data. The inventor of Bluetooth said that wouldn't work, and no one knows if it'll actually work in practice. But what Britain has done is make a centralized app with a centralized database, and then they've said that they're going to keep the data and that it will be anonymized, but everyone knows that's a lie because we've proven more than a decade ago that a list of anonymized data can be de-anonymized by just seeing where you go and what you do. You can quickly figure out who those supposedly random identifiers point to. And then they said they're going to keep the data afterwards for an indeterminate amount of time to use for further research. So it's very unclear, and there's pretty strong evidence that it won't do any good anyway. So anyway, people are talking about this. The point is, of course, that there were some famous cases. Typhoid Mary and John Snow were famous cases more than a century ago, where they were able to identify the person that was spreading the disease and mitigate the disease by tracking and isolating that person. And so they would like to think they can do that again, but there's pretty strong evidence that it's not going to work, at least not the way it's done with Bluetooth. This is pretty interesting. I've been working on COBOL and mainframes, and the older mainframes are so old that you can run a complete mainframe system just as good as a mainframe from the 80s on a Raspberry Pi because of Moore's Law. So anyway, it's you can process a lot of transactions if you use efficient languages like COBOL. Anyway, so there's a lot of attacks, and even though people spend a lot of money on security, half the attackers still eventually get in, which is not that much of a surprise if you think about penetration tests. Competent penetration testers always get in. So it is, there we are. It is not too surprising that determined attackers also get in. And this is a fundamental problem in this business. You can hire security experts, and you can buy devices and products, and yet they still don't make you safe. And so we're currently in this crazy world where he says the average company has 30 to 50 security solutions running, and yet a bunch of attacks still get through. So it is kind of driving everybody nuts, the proliferation of products and vendors and configurations to monitor, and yet the attacks still get through. It's a crazy time in this business. Things are pretty chaotic. This SALT vulnerability is awesome, and I just wrote a project for my class on Thursday night where you set up a SALT server and exploit it. SALT is a remote control system where you can send commands to a group of servers, and it's very popular for company servers, and a serious vulnerability came out. SALT has been updated, but not everybody has updated their servers, and it is a trivial command injection vulnerability that gives you root privileges on all the servers with SALT on them. So many companies have been hacked with this, Algolia being the latest one. In San Francisco, in the Mission District, they decided to test a large group of people. So they tested 3,000 people in the Mission District and found that 2.1% of them have active infection of coronavirus. And almost all of them were Latino, 95%, and 3/4 were men. So that is somewhat interesting if you want to know who's currently active with the virus, a lot of them having no symptoms, of course. Antibody tests are also now available. I'm going to get one next Monday. I'll let you know what comes of that. So you can tell if you had it in the past, which I think I did, but I'd sort of like to know. However, that doesn't necessarily mean you're immune because it has already mutated and the new version is spreading much faster, and no one knows if having had the old version makes you immune to the new version. The Trump administration is now preparing to mine on the moon. And since the moon is not owned by any nation, they are trying to develop a blueprint where you can put a man on the moon and then have some region around that that is considered your property and no one else is allowed to come poach your mine. It is not clear what they think they are going to find on the moon that could possibly justify the expense of getting there. But anyway, they're going to have some legal framework for moon mining anyway. So this is a nice analysis from New York Times explaining, we've been using lockdown to stop the coronavirus, and that is a very blunt tool. At a very high expense, we're all trapped in our homes, the business is shut down, people have lost their jobs. You can't keep that up forever. So the sharper one is contact tracing. And California, as far as I can tell, is the only state that's actually preparing to do this correctly. We have the smartest government here in the country, as far as I can tell. We locked down first here in San Francisco and shortly after in the whole state of California. And we're actually hiring a bunch of people to set up contact tracing. So we'll see how well it works here. I think we are the model for the rest of the nation. Schneier and Ross Anderson aren't fans of contact tracing. I see a student's comment. Phone apps, yes. Yes, I've heard there are several reasons to be upset about contact tracing phone apps. One is security and privacy. Another is that it simply won't work. Bluetooth has too high a range, and all it's going to tell you is if you were near some person who later was determined to test positive for a brief period of time, it's not necessarily true that you got exposed. And there are two great concerns I've heard. One is that you could easily create a denial of service attack by just telling people you had the virus and then wandering around when none of it was ever true, and make a bunch of people go into quarantine unnecessarily. And similarly, it's going to warn you just because your phone was near somebody else's phone for a while, even though you weren't exposed. And so you'll have to go in quarantine for nothing, and people won't put up with that too many times before they just remove the app and quit paying attention. And also, there are a bunch of people that don't have smartphone apps or won't install the app. And if you don't have a lot of people, a high percentage of people with the app, it won't work. So, they're hiring 20,000 people to do the phone tracing in California. Although the thing I last heard Gavin Newsom say is he's going to repurpose people who are already in the city government, in the state government, going to give them a job being phone tracers. So a human will be interviewing you and finding out who you exposed. And that is probably much more likely to work. It is really going to take like human interviews, like detective work, to do this, not just some app that tries to tell which Bluetooth signals it picked up. Anyway, we're going to do it here and we'll see how well it works. So anyway, here we are in 128. Here is the schedule. And this is 5-6. So I'm going to do the last lecture today, iOS applications. I'm not going to introduce any new topic next time. I might show you an extra credit project or something on a slightly different topic, but I'll just be here to help people who want to catch up by doing projects. I'm not going to have a lecture and a quiz or anything. So this is the last lecture. We've gone as far through this book as we're going to get. And let's see, Schneier talks about people putting phone on a dog. Sure, yeah, that's one of the many attacks you could do. Anyway, so I'll be here next week to see if I can help anybody, but I won't have a lecture. And the week after that is the final exam. All your grades should be in Canvas, and the announcements in Canvas show you how many points you need to get various grades. And if you are doing poorly, you can still withdraw until Friday, 2 days from today. So anyway, all right. So let's take a look at the attacking iOS stuff. Let me make this big. All right, so we're going to talk about the iOS runtime, inter-process communication, and injection. So the iOS runtime, this is quite interesting stuff, at least to me. So if you have Windows code, you compile a program and you run it, and it can dynamically load a library at runtime, but it is not intended to alter its functionality as it runs. But Objective-C and Swift do let you change the function of the app at runtime. I'm not quite sure why, but this is called reflection. Apps can change their own behavior. They can dynamically load new classes and change what methods run, so they basically are self-modifying code, which is clearly an interesting place for hackers to go. So a little bit of programming here. These languages are object-oriented, so they define structures called objects, and those objects include variables, methods, which are functions, and properties. And so here's an example. An interface file is what defines a class. So you have this file, and it has an interface that has the name of the class and the parent class, because it may be a subclass of a parent class, and then it inherits properties and methods from the parent class. Then you have variables, and then you have methods and class methods. Instance methods only apply if you have a class called a book. You can use the class methods as soon as you have that class present in your application. But if you want to use an instant method, you must have a specific instance of a book that you create. So it's not just the category book, it's one particular book that's created, and then that book would have a title and an author. But you could do things down here, like create a book with a title down here before a book has been created. So anyway, these are the various methods available to the class. So that's what this is. Instance methods can only happen after you have an instance of the class, which is a particular example of the category. And class methods can be invoked at any time as soon as that class is part of your app. So here's what it looks like in Swift. It's just another object-oriented language with a slightly different syntax, but you have a class name, an instance variable, instance methods, and class methods. So it has all the same structures. All right. So you call this instrumenting the runtime when you decide to profile the execution of the app at runtime. And so you can do things like bypass jailbreak detection. You can steal encryption keys. If they're stored in data, you can modify how the methods operate so they reveal the data. You can force loading view controllers, which we did in Android. You're able to jump to visible pages. You can attack local authentication methods that are used from one app to another. You could even pivot to an internal network. So your malicious app on the iPhone is able to send local network traffic out the way another app might and attack other resources on the home network. And you could therefore demonstrate what malware can do. If you have a test app on the phone, you can show that a malicious app could do this, and you can inspect encryption protocols. So Objective-C is the language that's easiest to instrument, so we're going to spend most of our time talking about that because it uses these things called messages that are like the intents in Android. So when it invokes a function, it sends a message through this Object-C message send function. And so if I can send calls to Object-C message send, I can simulate that and invoke methods. So they call this method swizzling. The class has a table of pointers. This is just like the global offset table in compiled C programs that we're exploiting in Linux and Windows programs in the exploit development class. So you have a list of selectors, which are names of methods, and implementations, which are pointers to the function. So it's calling library functions, and it's going through a lookup table to find them, which is called the dispatch table. And you can just modify the lookup table. So instead of finding the real functions, it finds your Trojan functions. And Swift uses something called vtable lookups, which is more difficult to instrument, although it can be done. And Cydia Substrate is part of jailbreaks, typically. As you know, when you jailbreak an iPhone, you see Cydia, which is what most people want, and that comes with Cydia Substrate. It's all done by using this swizzling technique. So tweaks are what's called substrate extensions, and these are dynamic libraries you create, and these are loaded into the app by the mobile loader in a jailbroken phone. So you can create a tweak and put it in dynamic libraries, and now that will have altered methods, which will change the functionality of apps that use those calls. And if you don't do anything more than that, they'll get loaded into every app. But if you want them to only get loaded into one app, which is far more common, then you add a filter, a plist file, and your plist file will be, if you have a dynamic library, mdsec tweak, you'll have an mdsec tweak.plist file. And that file just contains a filter. So here's what it looks like. It has a bunch of XML boilerplate, and down here it's got a bundle, and the bundle has a string, which is com.mbsec lab1-1a. And so this one is going to take the bundle identifier, and it's only going to inject this tweak into apps that are part of that bundle. So you can filter by any part of an app. And this should look familiar from what we talked about in the Android stuff. So there are development environments to help you write these tweaks. iOS, OpenDev, and Captain and Hook are around, but the favorite one in the textbook author is Theos, the one that works on the most operating systems and is recommended, and the one we're going to talk about. So you have 4 functions that are used by these frameworks, and here they are: MS Hook, find symbol, get image by name, and hook message EX. Those are the basic functions you use to implement tweaks. And so the MS Hook function is the main one. This puts in a trampoline, which is what we've been using in the exploit development class, a little short method that just redirects code to another location. So when you try to call a normal C library function, it instead goes somewhere else and runs a Trojan function. Then MS find symbol lets you try to find things by name, like names of variables or names of method, which usually will not work on most apps because most apps are stripped in compilation to make them smaller and to make them harder to reverse engineer. Get image by name will load a dynamic library, which is nice, and hook message X will implement message swizzling for the functions that have inherited from this object. All right, so here's an example. This is C code. So you include a couple of libraries. You have a static object called old stat. Now what we're going to do here is we're going to hook the stat function. Stat is a command line Linux function, an iOS function that will just tell you the status of a file, whether that file exists and something about its permissions. And the point of this is to conceal this path called bin/bash. So the original stat is here. Old stat will point to the original function called stat. And here's the new stat. And the new stat is going to just check to see if the path is equal to bin/bash, then return a message that says, I couldn't find it. There is no such file. Otherwise, run the stat function correctly. So this is what typical rootkits do. Typical rootkits conceal processes, folders, and network connections of something that's going on that you're not supposed to know about. And this implements concealing a folder from you. So this bin/bash folder will be hidden. Bin/bash file probably. Anyway, so that's all this does. And this is the actual active ingredient that implements the hook function, calling MS hook function, that replaces the stat function with new stat, and the old stat is over here. So that's what you have to do to hook something, and a rootkit consists of just a series of these things. All right, so Cycrypt is a runtime instrumentation tool using JavaScript and Objective-C, and it can do the same sort of thing. Brute force local authentication methods, steal encryption keys, force loading of containers. And so you can pivot to internal networks. If your app has the ability to access local resources and I can attack your app, I can get through. And this is what happens with bring your own device or mobile device management apps. People typically do install these, and then they're connected to folders and internal company resources through them. And this one here was vulnerable, at least in an earlier version, 2013. Kaseya, BYOD, you'd put this on your phone, and then you could use it to access company resources. And what it did was you'd install a Kaseya gateway server, and all the people running Kaseya secure browser could access things on the gateway server, and there was no further authentication. So this meant if you were able to compromise that app on the phone, you could compromise the internal company resources. And this has come back now because of the Internet of Things. Many home Internet of Things devices make the same assumption that if you are coming from a local IP address, you're authorized to compromise the light bulbs and thermostats and other devices in your home. So again, the same kind of weakness is there. And this is always for convenience. You don't want to make people log in a second time to get to company resources on their phone. So you assume that having an installation of this product on the phone constitutes authorization to access company resources. And that would be fine if the phone could not be infected with malware. and have this app attacked. All right, Frida is an alternative system. We've used it in some of the projects a little bit, although we didn't get too far into it. This doesn't use Cydia Substrate. So all you have to do is run the Frida server binary, and then you can control Frida over USB. Another way to do this is with the LD preload environment variable. This dynamically loads libraries. In Linux and in Mac, it's called delayed insert binaries. And you can set it equal to something, and now it'll be an environment variable, and it will be launched into every app that loads. So this would be something that prevents any app from detecting your jailbreak. All right, so inter-process communication is difficult on iOS because every app runs in a sandbox and it's not supposed to be able to talk to other apps. But of course, there are some cases in which you want to allow that. For example, the pasteboard. If you cut and paste something, the whole point is you're planning to paste it into another app, so the pasteboard is allowed to reach from one app to another. Protocol handlers are a way to call one app from another, and application extensions are deliberately there to make it possible to connect two apps together. So for example, there's a built-in one, which is this one, ITMS-apps. If you reference a URL beginning with this protocol handler, that will open the Apple Store. This is how your app can have a link saying, you should get our pay version or our sister app here. Click on this in my app, and it will then open the App Store and let you load this thing. So that's fine. But you can define your own UR schemes in your info plist file. So you could define something like my VoIP : and then everything that starts with that handler from any app will call your app. And then it would be your code deciding how to handle this, and your code might have defects. So you might, for example, allow it to automatically load. So on a web page, you could have an iframe. So anybody that views the iframe, it will then try to reach my VoIP, and that will call your app. So this is what happened with Skype. It happened with Skype in Android, and it happened with Skype on iOS. The Skype app would have a Skype handler, and you could just make a malicious web page that made a phone call. So they patched it, of course, but it was a vulnerability. Then there's application extensions. Apple gives you these so your app can do things that affect other apps. For example, there's a notification sensor called Today. I think it even shows up when your phone is locked. There's a sort of notification of what's happening today, and you can send a message to that. Okay, somebody needs help. Yeah, sure, after class. All right. Anyway, it might just be that the Drupal server is down. I have to bring it up frequently. It keeps dying. Anyway, all right, and then there's share content. There's a custom keyboard you could have. And then, of course, every app has to have access to that custom keyboard because your key presses are coming in differently. So it works like this. The app extension sits here. So one app can request to the app extension and get a response. And then the app extension connects to another app. So it's sort of like a proxy server. So one app does not directly connect to another app. It sends a request, and that app forwards the request. All right. As a matter of, we'll do it during the Cahoots. All right. So 1Password. Your password manager has to work this way, right? Your app, you're going to a website, you go to log in. Then I say, I want to get my password out of the password manager. So it uses the extensions to go ask the password manager, get the password, and pass it back. And that means, of course, that a malicious app could, in principle, get passwords out of the password manager too. All right. And then, of course, there's the injection attacks that are just like what we're doing in the web attack class 129S. You have a bunch of ways data can enter the phone. Web pages can come in, URL schemes, files you might open, AirDrop, Bluetooth, Wi-Fi, all these things send data into the phone. And each one of these may have errors where malicious data is misunderstood by the phone and does the wrong thing. UI WebView is the simplest one. So this is loading HTML files or PDF files or Office documents. And all those have ways to inject code into them. It's using WebKit. And for one common technique of injecting code is JavaScript. And you cannot disable JavaScript in UI WebViews. So that means if your app allows you to inject special characters like less than and greater than signs, you can inject script and it may run. So one example was the Skype iOS app. You could put script in your name. And then when somebody saw your name in an address book, it would run the script and you could steal their address book and send it up to a server. That's the kind of thing. You can have local data stored on the phone in SQLite databases. And SQLite databases can be vulnerable to SQL injection. So you can steal the data out of the databases with SQL injection. Now, on MS SQL or MySQL servers, you can often get command injection through SQL injection, but that's not so easy in SQLite. It's a more limited framework, but still you can steal the data. Then there's XML. XML is rendered by these engines, and there are various XML attacks. The simplest one is just to have nested XML entities. Entities are custom defined names, and you can define a name that stands for name 1 that stands for 10 copies of name 2, and name 2 stands for 10 copies of name 3, and name 3 stands for 10 copies of name 4, and make a bunch of layers of that until expanding it would just use up all the CPU and RAM on the phone trying to do that. That's the billion laughs attack. If you can parse external entities, then you can actually redirect traffic to another location on the local network. But that is not turned on by default, so that's more rare. And then there's file handling routines, which are what you call local file inclusion in the world of PHP. If your user controls something that is used for a file name, so if I can upload a profile pic in some kind of app that goes in JoePic and I control that name, the intention was just let me name my picture, but if you don't filter it, I can give it a name that starts with ... and then I can traverse up and go into somebody else's folder that I shouldn't be going into. So it's a common defect to allow people to put in these special characters. All right, I've got some Kahoots. So let me see if I can get them up. All right, looks like I got to bring them up here. All right. There it is. All right. Wait a few more seconds, see if we can get some more. I'm giving it 8 more seconds. Ah, here come some people. Good. It's much better if we can have more than 3 people. All right, looks like that's it. All right, which one defines a class structure? Okay, that's the interface file. All right. Which one contains pointers to methods? That's the dispatch table. All right. All right, a plist file that controls when an extension is loaded. Okay, that's a filter. Good. All right. And which tool blends JavaScript and Objective-C? Okay, that's Cycrypt. All right. And which item always allows JavaScript? Web views, good. Everybody's got that. Okay, I'll record the winners. Peter and Rich. Ken. All right. So, what's this? Now, here we go. All right. So I'm going to stop the recording, but I'll stick around to answer questions.